Okay, so what I've handed out to you is going to be both your notes and your homework. Okay, all in one. Okay, the first 2 pages, well, I guess the first page, front and back, we're going to go over together in class, and then the second page, front and back, is what you'll have due for me tomorrow. Okay, so we've talked about the first fundamental theorem of calculus, but we've only really talked about it in one context. Okay, we have not talked about it when it actually applies to a scenario given units. Okay, we've used the fundamental theorem of calculus to find function values, and we're still going to kind of do that. We're just going to have to put it in more of like a, hey, this is what's happening with units situation. Okay, so what I want you to look at is this right here. Okay, are you okay with the integral from a to b of f prime of x dx is f of b minus f of a? Makes sense, right? It's a fundamental theorem of calculus. Instead of little f and big F, I used f prime and f, right? Do you agree that f is the antiderivative for f prime? Okay, now, I'm going to add f of a over here. And what we can think of is that f of a is like the amount that we started with, whether it's f of 0 or f of 2 or whatever, it's an amount that we have. And then we're adding accumulation from a to b. So b is going to represent the total change after we start. Okay. So we have an initial amount, we're adding the change from a to b. So how much do we have left at the end? Okay. Now we're going to have to put this in context, and that's going to be the biggest practice that we have right now. Okay. So what I want you to do is I want you to read through this example number 1. We're working with a function called C of t. And what are the units of measurement for C of t? Cost in dollars per day. Does that sound to you like a derivative type of measurement? We're talking about something per and a measurement of time. Awesome. Okay. So C of t is representing a derivative. We didn't say that it's a derivative, but it's representing a derivative. Okay. With that label, cost per day, that is a rate. All right. So when we go backwards, when we take the antiderivative of this rate, what unit of measurement are we going to be left with? Cost. When we go backwards, we lose that per whatever time measurement we're looking at. Okay. So, like Isaac said, the integral from 0 to 60 of C of t to dt represents the total cost for the days t equals 0 to t equals 60. When you have those limits of integration, it's important that if I ask you to interpret an integral, you also tell me what the heck those limits of integration mean. Okay, so we're talking about the total cost from day 0 to day 60. Okay. Ooh. For D, I have that same thing, but 1 over 60 minus 0. What does that look like? Average value. Average value. Average rate of change is just normal slope. Average value is 1 over b minus a times the integral. Okay, so if we take this and we divide it by that 60, well, now we're talking about average value. So average, I'm not going to say value though. C of t represents cost per day. Okay. Average value, well, our C of t, our function inside the integral is cost per day. So now we're talking about average cost per day. We have done nothing different. We are just putting labels on our function. All right, go ahead and read through scenario number 2. Okay, so this time we're talking about V of t is the volume of water, and its derivative is the rate at which water flows into the tank. So we're taking the integral from t1 to t2 of this derivative. Okay, well, if we talk about V of t using this integral right here, the first fundamental theorem of calculus says this is antiderivative at b minus antiderivative at a. Now, what does this represent? Okay. What was inside the integral is the rate of water flowing into the tank. And so if I add up from time is 1 to time is 2, what do we have? What? Not quite. Average rate of change is always going to be like a slope. Okay. Change. Just change. Change in what? No, not rate. Change in volume. Okay. Okay. We took the integral of a function that was measuring the rate of the volume flowing into the tank. So maybe it's like milliliters per second or cubic centimeters per minute or something crazy like that. Okay. So when we go through the fundamental theorem of calculus, we now have just the volume and how much volume has changed from time is 1 to time is 2. Okay. All right, one more. Read through number 3 here. P of t represents the population of a group, and P prime of t, the rate of change of the population in thousands per month. Okay, so P of T2 minus P of T1. I want that rewritten. with P prime involved? Isaac, you wrote it down already. What'd you write down? Okay. The only thing I'm going to change is I want T1 to be my first limit of integration and T2 my second. And maybe you have it written like that. You just read it backwards. Okay. Because we want to plug in B minus plug in A. All right. What are the units of measurement for this right here? Thousands of people. Okay. What were to happen if I got like -2,000 of people? What would that mean? We had a loss in population. Okay, that's okay. This could be a positive number. This could be a negative number. Okay, talking about population, that's kind of depressing. But it popped into my mind that we better talk about this being positive versus this being negative. Okay, we're talking about the change in amount, whether we're adding or subtracting. Okay, so this is what I want you to do. On the next page, we have some group problems, and I'm going to break it down only a couple at a time. So I'm going to give you a couple minutes to, as a pod, talk through number 1 and 2, and then you're going to stop. Talk through 1 and 2, and then you're going to stop.
What does the interval from 0 to 180 RTDT represent? Yes.
So RFT is so you're going backwards. Yeah.
The initial amount of bees and then the amount of bees that are out of the curving gap.
1 and 2, and then stop.
So number 2 would be the initial amount of bees plus the amount of change towards the final plus the amount added to the, it's like, but it's from here to week 10. So it's under the initial amount of change and the final. The amount of bees added over the 10 or from 0 to 10. Just
So what's the end? Like how much? Okay. All right, let's go ahead and talk about these two. Okay. And number 1, oil is leaking from a tank at a rate of gallons per minute. I take the integral from 0 to 80 of that function. Okay. So, Henry, what does this represent?
We said that it was the gallons lost after 3 hours. It's like the change.
Gallons lost after 3 hours. I saw some people just have gallons written. That's not enough information for me. And you know what? I would actually maybe would even prefer after the first 3 hours. So that was specifying, hey, This is from the beginning. Or maybe you say gallons lost from time t equals 0 to t equals 80, or the first 180 minutes. But we are talking about gallons, that's important. But then additionally, it's gallons, since it's leaving, we're losing gallons in the first 3 hours. Okay, a bee population starts with 200 and increases at this rate. So we have 200 plus the integral of the rate. Okay, Gwen, what does that represent? The amount of bees added. So said. Okay, so I would say that this represents the amount of bees added. With that 200 there, how does that change it? Okay, so we have the bees added plus the initial amount. So what do we have? The total. We have the total amount of bees after the first 10 weeks, or the total amount of bees from time is 0 to time is 10 weeks. Okay, make sure you get the label of what this represents, amount of bees. Also, make sure you get the label of your limits of integration. 0 to 10 is represented in weeks. Okay. Do you see the difference in the two? This one, we're just talking about what is changing, how much has changed. Okay. Here we have the initial amount plus the change. So we have actually like the total number of what we're talking about. Okay. All right. You're going to need a calculator for the next two. Please look at 3 and 4, then stop, but you will need a calculator for both of them. I mean, technically number 3, you wouldn't have to have a calculator, but I'll be nice. Guessing you're gonna have to set something up to put into your calculator. Just throwing that out there. Probably not that. So we have a rate, correct? And I want the number of gallons. What are you gonna have to do with the rate? Yes, that's a good start. Good start. Okay, you're starting with a rate, and I want to know the number of gallons.
So before the broadcast.
Okay. So you plugged in, so what you have is the rate. The rate at which water is being pumped is this. In minutes.
1 to 12 is your 12.
Oh, in gallons per minute. So you found the gallons per minute. I want how many gallons? You given a function of gallons per minute in what gallons, how do you go from gallons per minute to gallons with calculus? And I'm saying the first 8 minutes, so the integral from 0 to 8. Like you have to take that into account.
So.
So that's not. From 0 to 8. Yes. Yes.
No. No.
This is all that you
Antiderivative. Why are you in parametric mode? Why are you in parametric mode? Or why are you using, oh, you're just using T's to be cool? Okay. You can totally use X's and it's fine.
Oh, that's a T.
Yeah, but it's okay if your calculator says that. It'll be okay.
I mean, it wasn't harder than anything.
Okay. Okay, let's talk about number 3. Kylie, what did you set up to get your answer in number 3? Mm-hmm.
30E to the 0.02T.
Okay, so the integral from 0 to 8 of our rate, it's a fun little rhyme, represents the total change in those 8 minutes. So 260 gallons has been poured into the reservoir in those 8 minutes. Okay, if you are given a rate, gallons per minute, and we need to get to gallons, antiderivative is what we need to do. Okay, add up that area under the curve. Okay, now, are you okay? Are you guys okay with that concept of taking the integral to get to gallons?
Yeah.
Or is that not like clicking? Do you need a picture visual?
Yes.
You do? Okay. Okay, so we're adding up a bunch of rectangles under the curve, right, for our area, essentially. Okay, so each of these has height something gallons per minute, and our x-axis are minutes. When we take area of a rectangle, no matter how skinny tiny it is, we take length times width. Well, what is gallons per minute times minute? Gallons. Okay, so there's the area interpretation for you. Okay, all right, so now in number 4, changing, okay, so here is this dollars per month. If this trend continues, what change in income can the average American expect during 2007? Okay. So Wyatt, talk us through how your group set this up. Okay, so let's talk through it. We're starting out with dollars per month. And I want to know what change in income can the average American expect during 2007. So how many months are we talking about? 12 months. And we have a function that is dollars per month. And I want to know the number of dollars that's going to change. Okay, so what do we need to do? Okay, what would our limits of integration be? How about 0 to 12? Right? Okay. It's like 0 to 1 is January. 1 to 2 is February. Okay. Of 40, boom, 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 boom. Luckily, you have a calculator. And when you plug that into your calculator, you get a nice $485.80. Yeah, I like 3 decimal places, except when we're talking about money. Let's be reasonable. Okay.
How would you do the first one without a calculator?
Well, we know that the antiderivative would be 30e to the 0.02t times 1 over 0.02. Like if we use U substitution. And then you evaluate it from 0 to 8. Are you with me?
Yeah, I mean, yeah.
I mean, you could do it. It would just take a little bit of work. Yeah. Okay. Last but certainly not least, we are going to look at number 5, but only parts A and B. So read through number 5, and then I want you to work through A and B. You can use your calculator on this one also. So in part A, you can totally use your calculator. I would suggest in part A, use your calculator. Math 8. Math 8 takes you the derivative. Oh yeah, math 8.
Oh, yeah.
Yep. It's like subtracting from a process problem.
Oh, is that just
Tons of.
one?
This-
Hours to travel.
Zero to eight. They processing this gravel and
Radiance, always radiance.
Oh. So if you like what John did before. Fire session.
All right, let's talk about these. So when you plugged in Math 8, I mean, you're welcome to take the derivative by hand, but if you have a calculator in your hand, do Math 8. All right. So, Matt, what did you get for your derivative? Yeah. I'm rolling my eyes. 3 decimal places. Thank you. Okay. This is the derivative of gravel arriving at the plant measured in tons per hour. Thank you. Where is it? Tons per hour. This is tons per hour. So first of all, what does it mean if our derivative is negative? That our function is? Okay, so the rate of unprocessed gravel arriving is decreasing at a rate of 24.588 We were in tons per hour. Now we're in tons per hour per hour. So tons per hour squared. We took the rate of tons per hour and we took its derivative per hour. So it's tons per hour per hour. Is that bothering you? No? We're okay with it? Physics, it's kind of like going from velocity to acceleration. Because that's a derivative relationship.
I don't understand it, but understand why hours per hours. I understand why we have hours per hours because it's derivatives. It's like
Yeah,
hour
exactly.
I don't know what that means like practically. What is tons per hour squared?
So it's tons per hour per hour.
Like, how does that what does that look like? Like
It's fall at 9.8 meters per second. So it's slowing down. It's the change in the, it's like the change. in
The change is decreasing. Yeah.
Okay, so they're working less fast.
The rate is decreasing. Yeah,
Yep,
yeah.
I'm with it now.
Okay. Now, the total amount of unprocessed gravel. We have the integral from 0 to 8 of g of t dt, which is 825.551. What is our label? Tons. Okay. Thank you, ma'am. So here's the deal. These C and D, they involve our rate in, rate out concept for tomorrow. So we're going to come back to these tomorrow, and I'd like you to turn the page, and on your exercises, number 5, C and D, I want you to make a note that we're going to save for tomorrow. Okay. So this is your homework. You have, man, 5 questions that look very similar to what we just did. You too. I will post my key to these 5 problems on Google Classroom. You are also expected to complete this free response problem that we will grade at the beginning of class tomorrow. My key will not be posted because we're going to go over it first thing tomorrow, and we are going to grade them with our red AP pens. Okay, so you have 6 problems. One of them with 2 parts, one of them with 4 parts, so 10 problems. You can do it. You can do it. You are welcome to use a calculator on anything on this worksheet. Okay, so we have 3 minutes. If you wanted to like answer the first 2, you like totally could.